Welcome back to our discussion of the network layer in our course Networks and Distributed Systems, based on a textbook by Jim Carose and Keith Ross, Computer Networking, a Top-Down Approach. We've been talking about addressing, and we are still talking about addressing, so let's pick up where we left off. The Internet's address assignment strategy is known as Classless Inter-Domain Routing. You'll see it abbreviated CIDR and pronounced CIDR. CIDR generalizes the notion of subnet addressing. As with subnet addressing, the 32-bit IP address is divided into two parts, a subnet and a host. And again, the dotted decimal form a.b.c.d/x, where x indicates the number of bits in the first part of the address or the subnet part of the address. The bits to the right of that are referred to as the host bits, and those bits are used to identify the host on the subnet. The x most significant bits of an address of the form a.b.c.d/x constitute the network portion of the IP address and are often referred to as the network prefix of the address. An organization is typically assigned a block of contiguous addresses, that is, a range of addresses with a common prefix. In this case, the IP addresses of devices within the organization will share the common prefix. When we cover the Internet's Border Gate Protocol Routing Protocol, or BGP protocol, we'll see that only these X leading prefix bits are considered by routers outside the organization's network. In other words, with BGP routing protocol, only the subnet portion of the address is examined. That is, when a router outside the organization forwards a datagram whose destination address is inside the organization, only the subnet portion of the address is considered. That is, as in the previous lesson, the /24. This considerably reduces the size of the forwarding table in these routers, since a single entry of the form a.b.c.d/x would be sufficient to forward packets to any destination within the organization. The remaining host bits of an address can be thought of as distinguishing among the devices within the organization, all of which have the same network prefix or subnet address. These are the bits that will be considered when forwarding packets at routers within the organization. These lower order bits, as they're sometimes referred to, may have an additional subnetting structure. For example, suppose the first 21 bits of the CIDRized address specify the organization's network prefix and are common to the IP addresses of all devices in that organization. The remaining 11 bits then identify the specific host in the organization. The organization structure might be such that these 11 most right bits are used for subnetting within the organization, as we just discussed. For example, an a.b.c.d/24 might refer to a specific subnet within the organization. Before CIDR was adopted, the network portions of an IP address were constrained to be 8, 16, or 24 bits in length, an addressing scheme that was known as Classful Addressing, since subnets with 8, 16, and 24-bit subnet addresses were known as Class A, Class B, and Class C networks respectively. The requirement that the subnet portion of an IP address be exactly 1, 2, or 3 bytes long turned out to be problematic for supporting the rapidly growing number of organizations with small and medium-sized subnets. A Class C, that would be the subnet mask of /24, would accommodate only 254 hosts. Remember that if all 8 bits are turned on, the number of possible addresses is 256. That gives you addresses from 0 to 255. 2 of the 256 addresses are reserved for special use. 256 addresses was too small for many organizations. However, a Class B, which had the /16 subnet mask, which supported up to 65,634 hosts, was way too large. Under classful addressing, an organization with, say, 2,000 hosts was allocated a Class B, that's the /16 subnet mask. This led to a rapid depletion of the Class B address space and poor utilization of the assigned address space. If there are 65,634 host addresses available in a Class B and the organization is only using 2,000 hosts, that means that 63,634 host addresses, valuable limited number IP addresses, are being wasted. Another type of IP address is the IP broadcast address 255.255.255.255. When a host sends a datagram with a destination address of 255.255.255.255, the message is delivered to all the hosts on the same subnet. Routers optionally forward the message into neighboring subnets as well, although they usually don't. Having now studied IP addressing in detail, we need to know how hosts and subnets get their addresses in the first place. We'll begin by looking at how an organization gets a block of addresses for its devices, and then look at how a device is assigned an address from within the organization's block of addressing. To obtain a block of ISP addresses for use within an organization's subnet, a network administrator might first contact its ISP, which would provide addresses from a larger block of addresses that had already been allocated to the ISP. For example, the ISP may itself have been allocated the address block 200.23.16.0/20. First 20 bits would be the subnet. The ISP in turn could divide its address block into 8 equal-sized contiguous address blocks and give one of these address blocks out to each of up to 8 organizations that are supported by this ISP. While obtaining a set of addresses from an ISP is one way to get a block of addresses, it is not the only way. Clearly, there must be a way for the ISP itself to get a block of addresses. Is there a global authority that has ultimate responsibility for managing the IP address space and allocating address blocks to ISPs and other organizations? Well, yes, there is. IP addresses are managed under the authority of the Internet Corporation of Assigned Names and Numbers, usually abbreviated ICANN or ACANN. The role of the nonprofit ICANN organization is not only to allocate IP addresses, but to also manage the DNS root servers that we talked about earlier. You remember our discussion of DNS. ICANN also has the very contentious job of assigning domain names and resolving domain name disputes. ICANN allocates addresses to regional internet registries and handle the allocation/management of addresses within their regions. This is probably a fairly short lesson, but we are about to get into the discussion of the Dynamic Host Configuration Protocol, which in itself is probably a decent lesson. So we're going to stop right here. Be sure to take a look at your notes and go back over this video. Make sure you understand these issues that we've discussed about CIDR addressing schemes. And when you're ready, come on back and we'll proceed to the next lesson.